our next speaker, Mariko, has come all the way from New York City for us today. She is a developer advocate at Google, does all things really cool open web stuff. She's also a co-organizer of Brooklyn.js. And if you happen to like crafts or things like knitting, and particularly happen to like the intersection of that and like tech, right, have a chat with her after because she has some really fun products, and you should totally check that out. That is not what she's talking about today, though. She's talking about cool, shiny, awesome web stuff that we should all be on the lookout for and we should know more about. So please give a huge round of applause to Mariko.
Hello. Is this on? Hello, is this micro? Oh yeah, it's on. Hello, hi, my name is Mariko. That's my Twitter handle. If you have any questions, concerns, comments, please do let me know. And I'm so embarrassed that like I gave that talk title a few months ago, and I just didn't realize that I said like such a big thing. But so I'm actually Japanese, and being true Japanese myself, my title is more like the web is actually okay. It's like it's fine. So the thing is, again, my name is Mariko. I work in New York City. I work at Google with a team that builds Google Chrome. And being the web developer inside a browser vendor exposed me to a lot of comments like, well, you think web is the best. And, you know, I'm an iOS engineer. And before we start the conversation, I'm gonna like make a conversation that like, I like iOS and not a web. And I'm like, dude, like, I don't really care. Like, I like web, you like other stuff, that's fine too. So anyway, so that's how we're gonna start it. So, this talk came through a year ago, almost exactly a year ago, last year, at a Chrome Dev Summit. We host a annual conference, and we had this little video booth where attendees can go up and then talk about like why they like the web. And announcing this, I was MC for that conference. Announcing this, my co-MC, Monica Dincluscu, she just like randomly said to me, like, so why do you like a web? And I was just not prepared to answer it. I didn't have the answer. And then like the thing I said was that the web is the only platform I built something on. So it's like, it's more like, you know, I didn't really shop around and decided to be web developer. I just like did only web. You know, so I have a somewhat typical tech story that I got access to computer and I got access to internet at age of 10. And my amazing parents let me use internet after 11 p.m. Supervised. And I discovered this whole internet communication. One part that is not typical of tech career is that I didn't get into coding. Like my parents are a technical person and math teachers. They gave me every opportunity to pick up into it. They didn't force me into it. I wasn't interested. I was interested in knitting. I was interested in origami and crafts and everything, but internet was my thing. So when I was thinking of like, what do I do with my life? I was like, I want to work at an internet company. I want to study internet. So that's what I did. I went to college, study internet. So the things that I would do at college was like lead Garden of Forking Paths from Bourgeois, or, you know, lead things as we may think. So Garden of Forking Paths is attributed as a first novel that kind of introduced the idea of hypertext. And then, as we may think, it's a Verge article from 1945. And the headline there is like super fascinating. It's like a top US scientist foresees a possible future world in which man-made machine will start to think. Machine learning, yes, AI. Anyway, so when I was figuring out what I want to do, internet communication was the thing I wanted to do. And that's what I studied, and that's how I got into not necessarily a coding. Coding happened accidentally, actually. And it's very fortunate that it is good paying financial choice, so that became my career. But my start was that I wanted to work in an internet company that makes communication tools. And that's how I got started, like kind of like a product manager job. So another story, last year, well, a few months ago, I was assigned, well, I chose to do a project thinking about how does browser actually work. This came in an interesting situation where I was sitting next to browser engineers, the person who writes C++ to make a browser, the application, and an expert web developer, my colleague, who know more about browsers more about web development than I do. And I was just listening to their conversation, and their conversation was not making sense to me, even though we were building a same application together. There was just a whole another level of like, oh, will that use like such and such thread, and will this do blah? And I was just like, hold on a second, what kind of lizard speak are you two doing? I don't really understand. And I realized that I need to understand the environment of which my code is running. So I took on a research project to research and communicate with other people who, like me, who might not know those things. So what meant was that like I need to dig through like 9-year-old's like YouTube video and watch like 45 minutes of VP of Now Engineering at a Chrome explaining how Chrome works. But what came with it was interesting results that in trying to understand how browsers are built, I watched a lot of video and I read a lot of article about why this new browser that they were building, whether it is a new version of Firefox or WebKit or Chrome, they were explaining a lot about like, here's a landscape 10 years ago, and here's the pain points that we have, and here's how we were changing it. So I kind of got to see the like evolution of how the landscape where front-end development and web development lived through. So I wanted to share how the web became what it is, guided by me, based on a lot of internet reading. So internet started, as we may know, as a way to share documents. You know, you need to hyperlink, and you can just share a document or research paper published in the other side of the world and just use a network to get those things without you physically going to library or getting fax machine. Well, I don't know what they did back then. But that internet, or the web didn't end there. It quickly gained the ability to style things, gained the ability to embed stuff, images. And I find it so fascinating that like the start of the IMG tag, the image tag, is documented in a W3C's mailing list archive. Here's Mark Andreessen, now VC, I guess, back then in the research facility building a web browser, saying like, I'm going to propose a tag, IMG. I have an implementation and I'm going to ship it. And that's how it became. And what's more interesting is that like all of those earlier conversations about what kind of things should go into the web, what kind of things that this hypertext markup language should support is documented in the mailing list archive. By the way, the first mailing list message on that thread is test again. If you open it, it says please ignore. I'm really curious what the number 0 message was that's not documented there. But what's amazing is that like it's open and there is a discussion and documentation about it. In fact, if you go W3C's website, you find it that the Open Web Platform is the collection of open, royalty-free technologies which enables the web. So the web from the get-go was built in open. It wasn't like some proprietary company and some product managers and business person decided like, well, in order to use IMG tag, you need to pay us like certain subscription fee and then like if you want to use like high resolution image, like there is another tier, like that's not that way. It's like everybody brought in the technology and the implementations and then bring it into the platform. So back then, when these things are happening, how was the browser technology looked like? It was a single process browser, and I will kind of cover what that means. So when I say process, in computer term, process, it's abstraction on top of your program. You can think of like your application code runs inside a process. And within that process, you can divide them into different threads to kind of like assign each tasks, but essentially like one unit of your application is a process. So if you double click on any of the application, you might see that window pops up and then your application starts. What's happening underneath is that when that icon is double clicked and the application is starting, a space in memory is reserved for a process. Process runs on that memory. And everything that happens on your application is stored into the memory, and that's how you know how this application is run. So if you close that application, then process also goes away, freeing up a memory. Cool? So far? Okay. So at the beginning, browser process was only one thing. Like it had everything inside one process. It had a code that controls a UI, that code controls downloading resources, that code that rendering the pages, everything in one place. And you might think that like, oh, this is all about desktop and things, but mobile web also existed from the beginning. You might not know it. I do, because I'm Japanese. Because so if you go to Computer History Museum in Mountain View, there's actually a, I guess, like archival entry on iMode. So the plaque says the iMode, information mode, phone by Docomo, 1999. Japan built the first popular system for mobile web access. So technically, AT&T had a pocket net that had access to the internet on the phone in US. But, you know, since the Computer History Museum in the United States is saying that this is the first, so I'm going to claim that my country did the first one. I guess the popular system was the key. I distinctly remember late 99 when everybody was switching to a mobile phone, flip phone, from pager. That was also very popular. Like every high school girl had a pager and then like send a message by going to public phone. Like you have a pager to display message, but you go to public phone and put like coin in it and then put the numbers to dial the message, and then your friend received the text message. That was the thing that's happening in Japan. So I do distinctly remember that the communication device shifted to mobile phone. So even though the service was released in 99, the development started in 97. And NTT Docomo made in my opinion, very key decision to choose HTML or the web technology for their, like, getting the content from the internet needs. For those of you who were doing mobile development back then, there was another proposed standard, well, not just proposed, it was in use, called WAP, that wasn't HTML based, that was another way. And if that had won or that had became a de facto standard, then in reality now we might be having a front-end web developer and front-end mobile developer who is doing completely different thing. But NTT Docomo decided that no, everybody's making website, like web is happening. We're going to use internet HTML because that's how you're going to get content publishers to publish. So this is the first phone, like iMode phone that you would have. Like it wasn't even a color screen. It had this tiny, tiny screen to display a text-based website. But what was amazing is that back then, if you have a mobile phone, which was affordable in my opinion, they had a lot of marketing. So like, I was high schooler in early 2000s, like, you know, not the first generations who got those phones, but like second wave. Like I can pay $20 a month and own one of those phones and have text message, access to internet, access to email. It also came with a email address, which is kind of amazing to have all, like the high schoolers in early 2000 had all of those accesses. Anyway, so iMode, this person who worked on the kind of like communications part of that iMode decided to use HTML. He actually read the HTML spec. He scaled it down and made what's called CHTML because iMode phone, like tiny screen with low power devices, probably single core CPU. Again, that and like low-powered environment compared to now. He was like, we don't need some of the HTML tags. I'm just going to leave the spec and delete the stuff that we don't really need. So that happened. Another critical invention of iMode was invention of emoji. But emoji came in with relation to web. So the phones for iMode had a browser that can download text and image in different sockets, actually. But back then, data was expensiver, and doing that loading and rendering takes a lot of memory space. So the guy who invented emoji had the idea where, what if all of the pictures or icons that commonly used are pre-installed to the phone, and all we do is send a code point to phone. So you only need to send text, don't need to waste the data on image, and on that phone, just display an image. Back then, iMode was trying to be kind of like an information mode, right? So they wanted to show weather forecast, they wanted to show news, and they wanted to have like some visual icons, not just like wall of text. So that's how emoji got invented, and that's a whole another talk and obsession of mine if you want to go into details about emoji. But point is, mobile existed. Mobile was built based on the philosophy of the web. Then 90s to 2000, here comes the rich internet application era. I don't know what it was called in UK or US. Certainly in Japan, we called it rich internet application, RIA. And this is the time I graduated college and I got into industry job. What it meant was your browser looked like this. Browser was basically a frame that delivers another frame that downloads content and then do something else. It was just like this place where a plugin will do something. And I remember my first job, there wasn't a front-end developer team or a split between back-end and front-end. It was applications team and the web systems team, where application team were a group of Flash developers who typically had like a game development study background, and then the web team was combination of now what we call back-end, but also PHP and HTML developer who would be building those frames that delivers those plugins. So it's a very different landscape. Of course, some people started using JavaScript and Ajax, and Google Map happens, and a lot of invention starts to happen. But this is typically the era where everybody was thinking of like, oh, web, there's going to be a black box or white box in the browser, and then inside of that, some other technology is going to figure that out. So what happened in that era of the way we build a web page or website or web app slightly shifting to plugin base. Well, browser also starts to change. This is around the time 10 years ago, Chrome shipped or came into the market. So the single process model that I talked about, you can spin up another process. One process on computer can spin up next process and kind of offload part of the work to a different process. And in between them, they can use what we call inter-process communication, or IPC, to communicate those stuff. What's the bad thing about this? Well, it's going to use a lot more memory space because each process needs to have their own memory space. But if, by separating those stuff, if one process goes unresponsive, and then say you have a graphics process that went unresponsive and your screen is frozen, all you have to do is just close the graphics process and restart it again. You don't need to shut down entire application. You just need to restart parts of the application and your application keeps going. So it's a lot more, gains a lot more stability. So currently, browser now might look like this. Whole bunch of process. Inside of each process have different methods. Or in Chrome's case, if your on like a powerful computer, it might look like this, many more process. In case of Chrome, they do a thing called servicification, which meant that Chrome, the application itself, gonna determine like, okay, how many resources can we use? Does this have a lot of memory? Does this have a lot of core on the CPU? And if so, then they split it up to many processes, because it's better, right? Like if device process fails, then, other process still keeps going. But if you are on like low-powered devices or phone, then Chrome might consolidate certain things to one process in order to save that memory footprint on your device. So we have a little bit of like smart, changing a little bit of architecture kind of work. We call it servicification. Anyway, so separate process means that one process, one part of the memory is going to run like UI and network requests, like, typically call it browser process. We might have another process for the web content itself where your application code runs. We call it an render process, probably the most key if you're looking at from web development point of view. And, if you have something like Flash still, plugin process is going to take care of that part. So multi-process architecture. Each tab became process too. For Chrome introduced the idea of each tab can get each own processes. What's good about it is that if one site have, I don't know, like very heavy operations or while true loop running or something, you can just stop that process and close that tab, and you don't need to lose any other tab because it's in the separate process. If all of the tabs will run in one process, then if one page gets unresponsive, then you have to close them all and restart the Chrome, and that's unhappy, right? So if you're curious about this, I have way more detailed posts on like 4-part series. Please do take a look. I have a lot of cute pictures. I promise it's not just wall of text. I really try to make it fun and a little more different introduction to as you might find it on code documentation. So it's not only me. Mozilla published an amazing array of blog posts with, again, another pictures. I love Link Clark's code cartoons. And also, like, you might think like WebKit or Safari as like a mysterious browser, but they do actually provide a lot of good blog posts about how the behind the scenes of browser works. So if you're curious, it's not just my blog post or Chrome, it's all of the browsers are doing it, and highly recommend reading. So in that era of multi-process architecture and a lot of things coming into the browser, what changed? Well, we've been talking about how powerful hardware became. Like, the hardware changing is what essentially allowed Chrome to go multi-process architecture. If hardware was still single core with limited memory, then we wouldn't even try to do those things. Another thing is evergreen browser is an idea that we have now. Like, it's amazing that once you restart the browser, there's going to be a new version of it installed. You don't need to think about warning users to move off of IE6 because that's like not supported. Like every 6 weeks, Chrome or Firefox just downloads a new version, and all you have to do is restart it. That's amazing. Another one is browsers are getting even more secure by separating those processes. And it became a lot of hot topic around January when Spectre and Meltdown security vulnerability happened. So a little bit of like why it's like separating processes are good for security. So as I mentioned, browser process that controls like browser tabs and network requests exist, and then render process that takes care of content exists. Render process, this one, is the most important part because this process is downloading arbitrary code from the internet and executing it on somebody else's computer. That's kind of scary. If you think about it, the web downloading the web and displaying the web in that way, it's kind of scary. So how does the browser make sure that nothing goes wrong? So, render process inside of Blender process, you might have application, you might deploy those applications saying like, oh, I have application, I need to update this data, I want to download JSON, or I want to have another XML file. So they say, send an IPC, into process communication, saying like, I need resource. And then browser process responds with like, okay, let's download it. But within the browser process, they will check first few bytes, the header part of the data, and checks if that's safe. What they were checking is like, is this a MIME type correct? Saying like, if somebody is sending, oh, this data is image, but if they were actually sending script tag, that can cause problem. Or this is where the safe browsing happens. So you might have gone to access certain website and then browser tells you, this is non-phishing site, do you really want to continue? This is where that safe browsing checks happens. And if they detect that it's not safe or that it should be blocked, then that data will never access the Blender process memory. That's important because with Spectre and Meltdown, anything in the memory can be read. And everybody kind of freaked out, like, oh my God, what do we do? So blocking those in a separate process is super important and key part of security. Anyway, so it's not just browser that gained a lot of like, well, now we are more stable, a lot faster. It's not just that. The web itself got a lot more capable. The use of web technology or where web browser is used changed from in front of big box computer using mouse to phones like this one and just tapping into it. So in order to accommodate that, web platform added, the pointer events that has a lot more granularity into how the pointer event works. Without pointer events, I cannot imagine writing a drawing application that can draw smooth line. Very thankful for that. As web application glue, people had idea of like, wow, I want to access local files because I want drag and drop local file and then do something and then like download the data again. So they added like file leaders. A lot, like, if you think about it, these tags or features on the web platform didn't exist like more than 10 years ago. It's amazing. So my first job out of college as a not a coder but working at an internet company was a video streaming application company. And whenever we have a new client, we would have this line item in our budget saying like, oh, and then our Flash developer is going to design video player. So that's going to be another $1,000. But nobody thinks like that. Like now, if you're building a video application site, nobody's going to think of like, oh, I need to hire Flash developers to build me a web player, or like I need to find a library that does a web player. You just use video tag, right? And then you might use JavaScript to customize certain things. But these primitives, the platform primitives did not exist and web gained over time. So what's coming next? I figured I should look a little further than what was done. And to me, 2018 started in 2017 seems to be that everybody's talking about WebAssembly or WASM. And for recap, WASM is a technology. It's a compile target for the web. So if you are writing application code, it can be anything like game, utility tools for the thing. You would write some kind of things in Rust or C++ or what have you, and then you would compile it to have on your desktop as an app, or it doesn't have to be a desktop, it could be a phone, but you compile it to be an app. Now, WebAssembly is the technology or the compile target to do the same for the web. So you might have seen in the context of WebAssembly, seeing like, oh, look, this very popular game is now ported to WebAssembly and running inside of the browser. So seems to excite a lot of people, but also seems to get a lot of comments like, so WASM is replacing JavaScript, right? And I'm like, I don't think so. And to me, well, the worst one is the people who's like, oh, now we can use grown-up language to write for the web. And I'm like, I'm kind of offended. I'm like, I love JavaScript. So to me, when somebody makes those comments, I feel like they have a mindset that the web's gonna look like this, and instead of Shockwave, they just gonna have WASM there. You know what I mean? They and rightly so. A lot of like flashy demos are like a full screen game on browser, and it's just like everything inside of this screen is run by WASM. But to me, WASM is not a replacement or the plugin that we had in Flash or Java applets days. It's more like supplemental thing. So I think we will have regular JavaScript web application using CSS animations and grid and everything that the new and great things that CSS is bringing. I'm sure it will have JavaScript frameworks that we love to use. And then WASM is going to fit in as one component of that inside of our web application ecosystem. One use case is that our team is building a WASM, well, we call it WASM application, but not in the sense of full screen WASM. We are building like web application that utilize WASM as a capability. One thing we did as a demo was try to make an image encoder and decoder in WASM. So what it meant is that we are building regular old web application that displays an image. But let's say you want to support this experimental file format that no other browser supports, but you still want to use it. So one of the engineers on our team wrote a decoder and encoder in WASM. We put it inside of a web application, which meant that we can serve a web application with very experimental image that no other browser supports. Like if you drag and drop into browser, it just cannot display anything. But because our application have a WASM module that has decoder and encoder, we can display those stuff. So those are the kind of use case that I see that WASM is going to fit into, and I certainly hope not go back to that plugin days. Another one I think that's come and perhaps a little, what do you call it? In English word, perhaps a little like biased towards, because I work with this team a lot, is that web applications gonna be concurrent, and then we start talking a lot more about web workers. So I'm gonna explain what that means. So we are making browsers do a lot more work now. Web applications are growing. We are sending a lot more data down the pipe. We are sending a lot more JavaScript down the pipe, although that makes a lot of people sad and a lot of people happy. That's a controversial topic. But in the sense that, like, network, we've been trying hard. Like, web developers has been code splitting and then trying not, like, de-zipping and trying to minimize the amount of data that we send for what's needed for the one page. Browsers has been working hard to make that one fast. DOM, or updating a UI, that's also a lot of innovation happened. People started to experiment with virtual DOM and doing frameworks, and people were trying to like figure out the way to better manage and fast do a great web interaction. But the result of that is that we are pushing a lot of computation into browser. So I just labeled it data processing, but like it doesn't mean that we are doing machine learning or statistics or anything. It's just pure computation. It's like, some frameworks, the JavaScript frameworks, use a JavaScript in the client to figure out layout so that they can update the DOM element on the screen better. But that means that a lot more computation is happening on the client side, and a lot more JavaScript is happening, which means it's going to block the rendering, which means is that when JavaScript is busy calculating all of the data processing or figuring out JSON or trying to find the data in whatever the object that you have, browser cannot scroll or display the animation, and ultimately all the experience gets junky or kind of like less good. So it's the problem. And web workers seems to be picked up as a solution by a lot of people. So web worker, if you've never tried it or heard of it, you can think of it as like two different things, a planet and the International Space Station. I usually explain web worker as so imagine we have a planet browser, right? So planet browser have elements, that's HTML elements, and the planet browser controls everything inside of it. They have access to resources, they can update them. I'm sure they can like make Earthquake and change new continent or whatever. And then we can launch another thing into space called web worker. And web worker, it's still connected by network communication line to process certain scientific experiments and certain calculations, but it's detached from the main planet browser, the UI. It doesn't, like, no matter how much computation that the web worker International Space Station is doing, how great of the scientific result is, the planet browser doesn't care. It's not blocked by waiting for that calculations. So kind of, it's the way of having a thread, sort of, for browser. So like in code, you can think of it as like new worker means launching the International Space Station. And then you use post message API to send the data back and forth. So from your web application, the main thread part, you say post message with data. On your web worker side of code, you listen to it on message event. And then they do some kind of high cost costly JavaScript execution. And then once that's done, then they send it back. The browser receives that data and then, might update the UI or something. In that way, if this part is taking, a few seconds to run, this part on the main thread doesn't need to be blocked by that work. And that's great. However, using web worker presents a lot of challenges. So does anyone really like programming with workers is an actual sentence I heard at a conference where Chrome browser engineers gather to discuss their ideas. And then I was kind of such a Stockholm syndrome of web development where I was presented with this is how to do web worker and never questioned it. And then this C++ engineer who does multi-thread programming completely differently, asked me saying, like, do you really like that way? And I'm like, now that you ask me, I do not like this. So there has been a lot of discussion about how can we make it, make using web worker easier? How can we make it so that a lot more people adopt using it? So the pain point one is we don't have scheduler as a platform primitive in web platform. So what that meant is that, the main application still needs to start a web worker, still needs to wait for that message. You need to have a scheduling system or queue system or whatever your architecture is, but you need to keep track of like, oh, I asked web worker to do this task, so when that comes back, then we need to do this thing. Those decisions right now needs to be written down in your application code, and there's no like scheduling primitive in the web. There was a proposal 2 years ago, but it kind of like went stalled, I guess. But the people who is trying to make this web worker thing happen, especially inside of Chrome, is picking up the idea and discussing how can we solve this problem. Another pain point is passing data between worker and main thread is challenging. So I explained that the main thread and worker communicates with post message. What that happens is that the main thread says like, hey, here's the data, can you use it? And then web worker says, okay, give me that data. And they need to transfer the data. There is a little bit of a nuance, but essentially they need to pass the data around. And first time I tried to use web worker, even though it is supposed to make your application faster and better, it became like slower because I was passing a massive canvas image. And every time I do the post message, I was just copying data from one memory to the other memory. And that took more time than actually doing the computation on the worker thread. So there's a lot of pain points going on. there was a great one called shared array buffer that can kind of like be in the middle, and then they can lead in right into it. However, with the Spectre and Meltdown, that is actually unfortunate that it's not available right now on most browsers, because the shared array buffer was used to do the Spectre and Meltdown attack. But if you're curious, there is a article by WebKit team that says concurrent JavaScript, it can work, by a WebKit team that goes into how they use shared array buffer to do the concurrent JavaScript web application work, and it's fascinating to read. Really hoping that when shared array buffer comes back, I can try this on. And then another idea is that, what if we can do stream? So there is a discussion going on to have a, listener on the main thread side. So you fetch some data, pipe it through, you get the stream, and then on the worker side, you just create a transfer stream to beam the data into main thread. But all of those are kind of discussion about like, how can we solve this pain point? The last one is that it needs more tooling. So if you are familiar with Web Worker, then you might be saying that, like, wow, this thing existed like many, many years ago. Why now? But if you think about it, Ajax happened because jQuery was so great to do XHR request. XHR request existed on web platform many, many years before Ajax revolutions happened. So I think toolings plays a lot in how we do web development, and Web Worker is missing that. My teammate, Sarma, has been kind of investigating that. So he has a thing called comlink, which is basically abstraction on top of that, passing the data and sending the message. And you can kind of set up your application to create a Web Worker and pass the message in between easier on the abstracted way. And then on top of that, he's building a library called Comuni, which implements actor model programming for using the, I know, using the that Web Worker. So those are the things. I hope you got a little inspired and you contribute to doing tooling. We certainly are experimenting a lot. Like, as I mentioned, we are building what wasn't involved web application. We are building libraries using web workers, and there will be a lot more coming soon from our team at Chrome. But if you have any ideas or any pain points, or you have this application idea and web is lacking that kind of capabilities, please do come talk to me. We are always happy to listen. I myself may not have answer immediately now, but I certainly will take it to engineering team. So please come talk to me, and I have a stickers if you do. Thank you very much.